Alright guys, welcome back to Algos Made Simple. Got an extremely easy one today. If you've seen us solve, or if you've solved on your own, longest palindromic substring, this is the exact same problem, just with a minor tweak. We're going to be looking for the number of palindromic substrings as opposed to the longest one. So it's almost the identical code, just, again, a couple minor tweaks. So with that being said, let's go ahead and dive into it. We're going to explain it as simple as possible and just go through this one again. It's almost a 2-for-1 because the more we understand this problem, the more we'll understand longest palindromic substring. The more we understand longest palindromic substring, the more we'll understand this one. So again, let's dive into it. Leetcode 647, palindromic substrings. Given a string S, return the number of palindromic substrings in it. A string is a palindrome when it reads the same backward as forward. A substring is a contiguous sequence of characters within the string. Alright, so I let the interviewer know. I understand I'm receiving a string, and all I want to do is count the number of palindromes in it. A palindrome could be one character, it could be multiple characters, it could be the entire thing. I just want to know how many there are. I don't care how long they are, just how many there are. So let's go here to the example. We got S equals A, B, C. So A is a palindrome in itself, B is a palindrome within itself, and C is a palindrome within itself. AB is not, BC is not, and ABC is definitely not. So that's obviously 3 right there. We come down here, we look at A, we've got 3 A's, there's 3 individual A's, so that's 3 right there. We've got AA, that makes 4, and this AA right here makes 5, and of course the triple A makes 6. So very easy conceptually to figure out what's going on here, not very difficult. But how can we program it? Well, again, I'm just going to assume that you haven't yet watched longest palindromic substring, but again, it's the same thing, so please take a look at it, because who knows if I'll do a better job in this video explaining it, or if I did a better job in the last video explaining it. I would recommend watching both. It cannot hurt you. So how are we going to attack this? Well, if you were just looking at each letter and saying, okay, is A a palindrome? Yeah, alright, now let me check and see if AB is a palindrome. Okay, now let me check if ABC is a palindrome. And then you go to B and you'd say, okay, is BC a palindrome? Alright, is C a palindrome? That's okay, the brute force way. I mean, it's okay. You could do it that way. But this optimal solution is super simple and even easier. And once you hear this one little take on it, it'll change the entire problem for you if you haven't heard it before. Instead of doing that and having that O(n) cubed, treat every single letter like it's the middle of a palindrome. So what I mean by that is we'll take a left and a right pointer, we'll have it on this character, we'll have it look at some criteria and see if that character, the left and right pointers, are the same. Okay, they are. We're going to bump our resolution by 1. Then we're going to expand out. We're going to expand the left out and we're going to expand the right out. So the left out to the left, the right out to the right. In this case, with the first letter, the left's going to go out of bounds, so we're not going to mess with it. But at this B letter, when we're treating that as the middle, we'll have our second palindrome there. It's going to expand out to an A for the left and C for the right. We're going to compare them together. They're not a palindrome. So then we'll come here to the C, treat it like the middle again, and we'll have our left and right on the C. That's 3. We'll expand our left, expand our right, nothing there. So you're really going to see the results of that when you come down here and look at this A, treating it as the middle. So you got your 1 right there, and then you expand out, expand, nothing there. But you come to this A, and you expand to the left, expand to the right, you do have another palindrome. So that's going to be great, and that whole terminology or whatever, treating everything like the middle, is fantastic. But there's one slight, so let me go ahead and put that in our game plan. Treat every character like the middle of a palindrome. Okay, so that's a game breaker for us, a game changer for us. So what is our only other problem? Well, there are odd palindromes and there are even palindromes. The odd palindromes are going to work just fine with us setting the left and right to the same character and then expanding out. That's going to work great. But what we're going to miss, because when we expand out from here, we're going over here, we're going over here, so we're already on a 3-character palindrome. We're going to miss these even ones, especially like these 2 right here. You're not going to be able to get that. So how are we going to get that? We're going to have something set up for the even as well. So we got to keep track of odd, or have something that will work for odd and even palindromes. But we're still going to treat the character as the middle what we're going to do is we're going to have the left pointer here and the right pointer here. So we're going to treat both of these kind of as the middle, and that'll give us one new palindrome. We'll bump it up by one, and then we'll expand out to the left and expand out to the right and do the same thing we've been doing. So what are we going to need to accomplish this? We're going to need a resolution variable, which will initially be set to 0. We're going to need a for loop to gather indexes. And then, of course, we're going to need something to check criteria. Check the criteria if it is, in fact, a palindrome. So, of course, the main thing on that is going to be, does the string at left equal to the string at right? If that does, then we'll bump our resolution up by 1. And then we're just going to, once we've done that and found a palindrome, we're just going to expand the left and right until we can't anymore. Alright, so the game plan I feel like is pretty simplistic, but I think it gets so much simpler with the code right here, guys. So just take a look right here. We've got count substrings, and we're passing a string to it. We're going to say resolution equals 0. So we've got no palindromes yet. How are we going to get palindromes? Well, it's time for our for loop, guys, because that's the only place we're going to be able to gather information here. So we're going to say for I in range length of the string. Okay, so that's going to gather every single index. And what do we say we want to do? We want to treat every single character, every single index character, as if it was the middle of a palindrome. So we're going to have our odds right here. So you can go ahead and put odd if you want, or you don't even have to put that. It really doesn't matter. And we're going to put left equals I, and we're going to have right equals I. So they're on the same character initially. And then what we're checking is, so it's time to check. We've got something. We have a potential palindrome here, so it's time to check it already. So we're going to say while left is greater than or equal to 0, that just makes sure it's in bounds, and right is less than length of s. So again, that checks and makes sure it's in bounds. And now what's our main thing I told you is the criteria. If that left equals the right, we're in business. It's a palindrome. Get excited. We're rolling. So we're going to say and string at index left equals string at index right. If that is the case, then you know what we're going to do. We're bumping up our resolution by 1. Well, what else are we going to do? We talked about it. We found this palindrome right here. We've got it. Well, that's awesome. Great. What can we do now? Well, we don't want to go to the next letter already because there could still be some meat on the bone here. This could still be part of other palindromes. So we're going to expand our left and expand our right like we talked about. Well, how do we do that? Well, the left needs to go left and the right needs to go right. So it's going to be left minus equals 1, and it's going to be right plus equals 1. And that's awesome. That's going to get us every single odd palindrome. We're going to take account for it, and we're going to add it up to it and just be fine there. But what about the even? Okay, so for the even, and you can keep this in the same for loop. We don't have to do anything specific. We don't have to put any conditionals, because if it's an odd, it'll work in this one, and it won't work down here with what we're going to code up. And if it's an even, it won't work here, but it'll work here. So we don't have to worry about coding up any kind of conditionals and figure out if it's odd or even. Don't worry about it. You're good. So the only difference is going to be our left is still going to be equal to I, okay, which has not been changed. This is all happening in the while loop. It's not going to come out and affect this left when we get outside here. So we have left equal to I, and you're going to have right equals I plus 1. Okay, and then we're going to go. And of course, what I mean is we're not going to come out of here and be able to do the even. We're going to come back up here and reset up here at the top. But anyway, getting here, we got left equals I, right equals I plus 1. And then all that's going to happen, so we're setting, for our palindrome, we're looking at, this is our initial middle of our palindrome. All right, and then we're going to do this. We're going to say, we're going to check and see if it's a palindrome. So we're going to take this exact same thing, and we're just going to paste it down here. And you could, create a function for this if you wanted to, but we're not. We're just going to try to keep it very, very simple. So it's the exact same thing. We're saying while left is in bounds, while right is in bounds, and S at index L equals S at index R. S at index left equals S at index right. If that's the case, bump that resolution up and let's expand and try again. Alright, you did it again, we're good. Bump that resolution up, expand again. Alright, we did it again. Bump the resolution up, expand again. Okay, this time we didn't. Alright, go all the way back up here, go to the next eye. Let's check if it works for odd. Let's go to even and do the same thing. So after all of that, the only thing we have to do, because our resolution is being updated the entire time, once we're outside of the main for loop, we're just going to return resolution. And it is as simple as that, guys. The only keys, there's two small thought processes keys to this problem. And I think you can get the rest of it without breaking a sweat if you have these two keys. Treat each character like it's the middle, and you've got to do something about odd and even. So if you were looking at this problem and you'd forgotten all about this, you hadn't seen it in a while, but you remembered I got to treat every character like it's the middle, okay? And I got to worry about odd and even. So for an odd one, this would be the middle. For an even one, it's going to be a 2-character middle. And then I'm going to expand. That's all there is to it. So thanks for watching, guys. I really appreciate it. Please check out Longest Palindromic Substring. I think I went more in depth in that one because it's the first time I've kind of encountered this. I probably didn't do as great of a job as I'd like to on this one. I think I still explained it pretty simply, but I took a lot more time in the previous video as it was more new to me. And hopefully you got a lot out of this video though and realize this is just not that bad at all. Again, I appreciate you guys watching, and we'll be back with another one shortly.